Welcome to another class with me, Ming. Today we talk about Introduction to Vector Algebra. Um, here are some of the properties that you should know about vector. That is the vector addition. When you add two vectors together, you will always get a vector, and that they are commutative, so it doesn't matter, the order does not matter. A plus B is the same as B plus A, and the grouping does not matter. So A plus B first plus C is the same as B plus C first, then A. So the grouping doesn't matter, that's associative. And there's a zero vector. Zero vector is basically is 0, 0 in a column vector form. This is going to be written as 0i plus 0j. In this case, these are the basis form. All right, in 2 dimensions. In 3 dimensions, this will be, for example, 0, 0, 0. Okay, and negative A just means it's the vector in the opposite direction. So, for example, if this is A, then negative A is this. So this is negative A, and over here is A. When you are writing this on paper, just make sure that you write your vector with an arrow on top. Here is a vector can be represented using a diagram as this, and you can think of it from here going to the end here. So the beginning to the end, usually use an arrow to represent it, and this written this particular way, that is the basis vector I and j. I is basically 1 unit to the right, so this is my I. So in this case, 3 units means 3i, okay? And here 1j is 1 unit up, and 2j means 2 unit up. So this is 3i and 2j. It can be also written this way. In this particular way, this is called the column vector form. Here is the y and here is the x. So y on top, x below. So the magnitude of a vector is basically, you can see it's the distance or the distance of the height from the beginning to the end, beginning here to the end. And from the right angle, from this right angle triangle, you can see that we simply use the Pythagoras theorem, that is 3 squared plus 2 squared. So in this case is 9 plus 4 square root of 13. Because it's a distance, this is always going to be a positive number. So in general, we have this. All right, that is for any vector ai plus bj, then this is my formula. It can be written in a column vector form as well. A unit vector is a vector that has 1 unit in its magnitude, and this is the formula that we use. So for example, say let y be equal to, let's say, 2 and 3, for example, in this case. So then the unit vector of this means that I have to first find the magnitude. This is 2 squared plus 3 squared. So this is 4 plus 9. So this is square root of 13 again. And the unit vector can be written as, usually with a hat on top. So this will be just 2, 3 divided by square root of 13. My answer, that is a unit vector. The length of k multiple of v is just simply written this way, and kv in this case is parallel to v, for example. So that means these are in the same direction. So now let us look at another example. So this says that find the vector of u such that it is 2 units in the magnitude and in the same direction of vector v. So what we need to know then basically in this case is u over here is just 2 of the unit vector v. So I get the unit vector v as 2 square root of 13 and 3 over square root of 13.